In this video, we will explore why 5 times 3 is equal to 3 times 5. Or in other words, why does it not matter in which order we multiply numbers together?
We think about a calculation like 3 times 5. One way that people would understand this is it's 3 added to itself 5 times. So this is 3 plus 3 plus 3 plus 3 plus 3. Now if you add all that up together, you get 15. Now some people might say it's the other way around. This 3 times 5 actually means 5 3 times. Or we could say 5 times 3. Now if we said 5 times 3 to give 5 plus 5 plus 5, we add this together as well and we get it as a total 15. So we get the same answer regardless of whichever way round we add it. The way to understand 3 times 5 is as the number of squares in a rectangle of squares. So the rectangle here is 3 by 5, and we can see if we do it by rows, the first row is 3, but all the other rows are 3. And I've highlighted the different rows there. Count them up: 3, 6, 9, 12, 15. Could we count up the squares of the rectangle in a different way? So let's take the rectangle, copy it, and now we're going to spin it around. Oh, spinning around. And now look at the rectangle on the right. And again, we're going to count by rows. First row, 5. Second row, 5. Third row is 5 as well. So counting them up, 5, 10, 15. Same number of squares, although we counted them completely differently.
Now you might say this doesn't prove anything. You've shown for one particular sum, and also it's relying on a visual picture of a rectangle. And you might say, well, what if you're blind? What if you've never seen anything in 2 dimensions before? How would this argument work? So let's see if there's another way we could show this to be true.
We have a slightly different way of thinking about it. 3 times 5 we could say is 5 groups of 3. For example, we could have 5 fields, each of which have 3 sheep in them. Is this the same number of sheep if we had only 3 fields but had 5 sheep in each field? In each case, we'd be counting the number of sheep. So if we can find some way to keep the same number of sheep, then we'll know that these are equal. So what if we take in each field, we colour each sheep red, blue or green, and then we could put all the red sheep into one of the fields. So that first field, we put all of the red sheep. And now we've got 2 more empty fields. We could take the 5 blue sheep and put them all in the second field, and then you can see what happens with the green sheep. And we can accept we have the same total number of sheep regardless of the order we have counted them in, and therefore the number is the same. 3 times 5 is the same number as 5 times 3.
So should you think about this every time you multiply numbers? No. Goodbye.